Welcome back, all of you, to the online tutorials for the subject Remote Sensing and GIS. In today's class, we will be starting Module 4, that is about data models of GIS. In the Module 3, we studied the fundamentals of GIS, what are the various components of GIS, and type of data in GIS, spatial data and non-spatial data. We also discussed that is vector data, raster data, non-spatial data or so-called attribute data, their types, their models we discussed in the module 3. So in module 4, we will be discussing about different data models in detail. So already we studied the like in the GIS domain, the data can be represented using two models. That is, one is a vector data model and another one is raster data model. So these two models are the way in which the real world features will be represented in the GIS domain. So today we will be learning about the vector data model, their representation using the simple features, how the real world features will be converted into a vector data model. That portion we will be discussing today. So about the data model, which are the conceptual models, can be done to the real world features. This describes as the representation and storage of geographic data. The data models used in the GIS, as I already said, vector data model and raster data model. So, looking into details about the vector data models in today's session. Vector data models are the representation of the real world features using three different forms, that is point, line, and polygon. So already we know that which are the features will be converting into point, line, and polygon. So in detail, we are going to observe each one today. And the vector data model, which is the two-dimensional representation of the data models in the XY coordinate system. So the first, the data form or the features will be represented using the point form. So which are the zero-dimensional objects which are having zero dimension, which are having single location in the Earth surface will be converted into point features as examples like a single tree or a single standalone building or a well or a windmill, etc., or a tower, which will be having only single location and zero dimensional features, which will be represented using point and line form. The all the linear features which are having linear characteristics like a road network, a river network system, a pipeline, or a electric distribution cable network system. Such things can be represented using a line. If a group of line is using for the representation, then we will call it as a polyline features. So here you can able to see a linear based feature like a road or a curved log, how it will be converted into a vector line when it is converted into a vector format. The curved edges, it will converted into a sharp edges using the line features, and the entire the road or whatever linear feature will be converted into a network of lines, so called polyline. Then polygon area based features will be converted into a polygon or a closed polyline, I can say, or a group of polylines will be using for the construction or conversion of a feature into a polygon. Like area based features, what I mean is a lake, I mean a full lake system, a river basin system, or a watershed, or a forest area, or a district, or a village. Any area based features will be converted using the polygon. So here, if this is a boundary of a lake or a pond area, which will be converted into a group of polylines or closed polylines or polygon in the GIS domain. So this with this chart, I was just making more understanding about what are the examples we can provide for a point vector model. As I said, zero dimensional features which are having single location, a town, a a triangulation pillar, or a windmill. So here you will be getting a doubt like a town. How can it be represented using a point feature? So it is an area based features, right? So again, I should say that for the conversion of a point and polygon, it depends upon the type of project we are doing. Say what is for what we are giving importance in the project. Say for example, if we are preparing a particular town map or a district map of an area, then each individual feature will be which are having zero dimensional feature will be represented using a point feature. But if we are doing for a state map, in that case each feature cannot be able to, or each single dimensional feature cannot be represented using a point feature. It will be a complex work. In that case, then the town or villages, it will be represented using a point form itself by providing the non-spatial data in detail. And coming into the line form, all the linear features, you can see that a river, a road network, a railway network system, the boundaries of districts, states, etc., can be represented using a line form. Then area-based features, a desert, forest, political units, a state, a marshy area, a wetland, or a lake or a reservoir, which are having a area-based feature, can be converted into an area form or polygon form. Okay, so now this two types of, I mean, the vector data models can be represented in a spaghetti model as well as in a topological model in the GIS. So spaghetti model means it is a simple vector data representation. There, I can say that the quality of such vector data will be having less compared to a topological model. In the topological model, we know that the topology, that is a mathematical term. Here, in the case of GIS, it is using for the to increase the accuracy of a vector data representation of the real world features. By applying the various rules in the topology, all the the repeated data or a duplication or missing of lines, gaps in the line, such errors will be getting rectified in the topological model, which can be used for a very accurate result based project, or but if it is a small practicing purpose, or if such project or such activities or training we will be, or we can use with the spaghetti model itself. But in the case of topological model, where the result of such project having heavy weightage, and there should not be any lacuna or deficiency with respect to the result of such project, in that case topology is a very must process has to be done, and topological model will be having high accuracy compared to a simple spaghetti model. So here the topological model I will be discussing in detail now. So spaghetti model, as I said, it is a simple representation of the real world features using point, line, and polygon. And while we are discussing about so here you can able to see the each features using a group of spaghettis, or here this each portions I can call it as each spaghettis. So the word meaning itself, you all know that the piece, or the each element, we can call it as a spaghetti. So coming to the topological model, where the data model is characterized by the inclusion of topological information within the data set. Topology is a set of rules that models the relationship between the neighboring points, lines, and polygon. So as I said, by the usage of the topological rules in the digitized vector data models, the duplication or the errors or missing of lines can be rectified using different types of topological rules, like connectivity, continuity, and containment. So one by one, we will look into this each topological rules which can be done to the vector data model. So first one, connectivity. Especially the connectivity will be applying to the linear based features like a road network. If say suppose here you can able to see if this is a main road after the digitization I'm telling, and here another road or another small road which is joining to this. So after digitization, you can able to see here if the proper joining between this for the I will name it as X and Y. So X is main road and Y is a small road. So if the joining, if it is not properly, the analysis cannot be done in a proper way. So this type of missing of lines that can be rectified using the connectivity topological rule. So if it is applying automatically, this will get joined properly to this particular main road, and the analysis and such work will be easy if we are rectifying the existing errors in the road network or linear feature based network. Continuity coming into the like so for example, if here you can able to see two polygon based features are here, one is C and another one is D. So if two adjacent features are represented with this polygon, and here you can able to see which is sharing a common boundary. Suppose here this is a district you have and another a nearby district is here. I can represent this is as A and this is a B polygon. But here, in the case of a normal spaghetti model, we have to do the separate boundary for the both the polygons separately. So here in the spaghetti model, the separately we have to do the boundary for the each adjacent features. But in the case of if we are applying the topological rule here, what will happen? This common boundary here you can able to see here the two boundaries are separately shown to segregate A and B polygon. But in the case of a topological model, this separate boundary digitization is not required, and it will become merge and it will become a common boundary. Even though the common boundary is present, the two polygons will act as two different entity itself. It will not be considered as a single entity. That is what continuity topological rule. Now coming to the containment, this is if within a polygon feature, if another polygon is present as part of or another feature entity. Say for example, if here the if this is a lake and which is represented using a polygon, inside the lake area, if there is any small island is present like this. In this case, that both the polygon to be acted as a two separate entity. But in the case of spaghetti simple model, if we do the digitization like this, the both will act as a single entity. It will not get segregated as a lake and an island. But by the application of containment topological rule here, this particular polygon will act as a separate entity and this will act as another entity. So it is very clear for the interpretation and analysis work, because this polygon to be considered as separately because it is another particular entity which is present inside this particular. So another example I can give is a stadium in a ground, or in a college campus if there is a separate playground is there. So both to be segregated as a two separate entity, not as a single entity of the boundary of the college or something like that. So that are the different advantages of topological tool. So coming to the, yes, here once again the diagram is showing the how the normal simple spaghetti model will be, and after application of topological tools how it will be. Here you can able to see this particular small polyline which is crossing the XR portion of vertex, but by applying the topological rule or tool here, this became proper, and this particular error is getting rectified here. So here also you can able to see improper edges that is getting rectified in this topological model. So we can conclude this topic with the explanation of what are the importance of topology. So this is very important. You will be getting a question in exam also. Explain the different data model representation in vector data, and also you will be getting a question. Also add a note on the importance of topology. So as I said, the topological corrections will increase the quality of the work or the digitization work, and it will give the proper assurance for the data quality, enhance the GIS analysis. So, as I said, any type of land use land cover analysis or a road network analysis or any type of analysis, the error free vector data to be required to get a very proper analysis. Then if we are not doing the topological correction also, we will get the result, but compared to the actual accurate result, it will be having huge variation. So as I said, so very major projects like traffic management or a road network or whatever type of project if I take also, the quality of the work or the output which is given by a topological database will be having high impact on the like accuracy of the result. So these 2 points are very important, and in detail I had mentioned here, and in the notes also you can read it completely. So in a nutshell, it will increase the quality and it will enhance the other spatial analysis of GIS works also.